or like whatever the advantages happened during that time. So this is a brief history, like it's a why we are treating the health information very securely. It's not only our personal interest, and also like it's a government mandate that we have to follow these guidelines and rules. When it's come to the analytics, like it's a why we are very strict about privacy and anonymization in analytic and IT development field, because like the HIPAA mandate that the data can be viewed and processed only for three kind of a thing. One is the treatment, another one is a payment, and third one is the operation kind of a thing. Treatment, any health service provider, the nurse, doctor, or like some nurse assistant, anyone can come and take the look at the data while treating you or helping you. That's the one. Second one is the payment, like it's a billing provider, bill provider. If you have any dispute in your amount, at the time they can look at the data. And also like your health savings account and the flexible savings account, those are the things. The operation things, like whichever, like the computer operation, like the claim processing, another thing, that's what. But our analytics, IT development, anything does not come under any of these three categories. That's the reason we have to decrypt the data. Sorry, identify the data. When it comes to the HIPAA anonymization standard, like it's a HIPAA recommends, hey, there is a two way, like a major way you can de-identify the data. One is an expert determination, where like you can apply any statistical or mathematical approach and go and de-identify the data. One of the example is a k-anonymity, is the one like the which falls under like it's expert determination model. The next one is a safe harbor, which is much more stricter and mostly used in many of this organization, health service provider organization, like it's a CVS Health, like USG. I'm not sure about USG, but like CVS Health is very strict about it, and we are using it. What the safe harbor mandate is, whenever you are sharing the data or using the data, the PHA data, you have to strip off 18 different kind of elements from the data. And you have to substitute that. You can substitute those elements by something different than that. When you talk about it, like it's some name, your address, geographical information, street, town number, state, all those things need to be removed. And when it comes to your zip code, we cannot use all 5 digits of the zip code. Only like it's the first 3 digits of the zip code can be used. Even when you are using the first 3 digits of the zip code, there is a mandate that like if the total population for the 3 digits of the zip code less than 20,000, you have to go and assign them 000 zip code. So they will be put into the common bucket. The second one is like comes to the date. You cannot use the date of birth, service date, date of death, all those element as is. When it's come to the date of birth, you can use an age. You have to strip off like the month and date, but you can use the year as is. And service date and all those things like the same kind of a thing. With respect to comes to the age, if the patient is above 89, we cannot use them date of birth. We have to put them in a common bucket called as like the 89 plus. The next one is like we cannot use the telephone, email address, and SSN for obvious reason. When it comes to like other unique identifier, like MRN number, account number, member ID, all those things we should not use, because if I know your member ID, I can easily go and match with like my plain text data and find out who you are and like what is your condition is. That's a restriction. Okay. Let's talk about a beer. The left one is like what you are seeing here is beer company, which is in Hop Meadow beer company, which is in Hartford County. If you look at the picture, like the entire manufacturing process, bottling, and customer service, consumption, everything happening in under one roof. The right side is like it's Budweiser's brewing company's northeastern facility. just in a couple of pictures, we could able to show like the brewing capacity and bottling only. Because the moment it's become big, there are a lot of automation and other elements and guardrails, everything comes into the picture. That's what.
Did you get to take those yourself?
No.
Did you get to take those pictures?
No. This one mine, like not this one, like it's I got from Google. Okay. No. So when the company is really becoming big, it's becoming more complex. Like it's a more complexity comes into the fabric, like a data governance fabric and data protection thing. Why I'm saying that is like the company like is a couple of healthcare companies is in like is a Fortune 10, like they are like kind of like is next to Amazon and Walmart. They make so much revenue and also they touch like so many people's life. And when you go and look into the big companies, like they have a multiple line of business. If you go and look at the healthcare, like the healthcare insurance is a major business. They may have like the payment card, like PayFlex or all those things, they will be having it. When it comes to the pharmacy, it's a pharmacy benefit, retail pharmacy, and specialty drugs, all those things, it will be there. Other services, primary health, senior health, like it's a health hub and all those kind of a thing. And also they will have a retail. When you have like the different line of business, when you do the vertical integration, Department of Justice brings into the additional complexity. Hey, you cannot share certain data from one line of business to another line of business. Okay. So we have to secure the data much more strict than what HIPAA recommends. That's the reason we go and follow certain implementation. Couple of them is encryption, and another one is anonymization, which is de-identification. Many of the people in our industry think, hey, you encrypted the data, so it's a de-identified. I can go and use for any purpose. No, it is not, because if you encrypt a data, you can obviously decrypt and you can see who they are as. Yes, it's kind of like some thing. If you put a mask, it will make you as some other person. The moment you remove the mask, it's going to be the show your original face. That's what it is. And anonymity, like if you apply something, like it's even though if you are trying to remove it, it's not going to show who you are. That's what anonymization is. Yeah. Just small comparison. Hey, what with respect to HIPAA? Hey, with respect to encrypted data, where I can use it's mostly for internal use and less restrictive use cases. I cannot share this encrypted data to my partners, data partners for any reason, because it's either encrypted and still it's easily identifiable. The manner how we implemented the encryption. When it's come to the anonymization, we will strip off all the personal information, and yes, this information can be shared for further analysis, like it's for research or any other purpose. This is an example, like hey, how a data look alike in the encrypted way and also anonymous way. If you see the like the plain text value in the second column, if you do encrypt or mask, it will produce a different kind of output. Like it's not a human readable, like you cannot make any sense. But like each and every value, name, address, zip code, and unique IDs, it will be encrypted, and it will produce the output, the ciphertext, without compromising any referential integrity. What I mean is, if I encrypt one data, anywhere at any time, it's going to produce the same kind of output. That's what is the goal of our encryption is. We use something called like a format preserving encryption using FF1 algorithm, which is patented and used by the Voltage. That's what we use. The next one is comes to the like some date of birth or like age and service date. Certain cases we won't encrypt the date of service, but we always mask age. The reason being is if you encrypt, if you want to go and do analysis, like it's you have to decrypt all those data before you go and apply them any restrictive. So what it's going to take a lot of computation and it's a lot of energy at any big data environment. So we mask it and we will give a privileges of unmasking only to the certain people who deliberately need it. It's most likely it's to like data scientists, and it will not be given to the any data engineers or those things until absolutely it's necessary. In other hand, if you come and look at the anonymous data, and first thing like is we will be strip off the address name, but in the place we will be creating a tokenization. I will go and talk about the tokenization later. And when it's come to the zip code, you can see like the 106105 it's become a 06100. And like it's the other dates, it's everything, including the date of service, everything becoming stripping off like month and day, only it retains year. It's little bit like about how we implemented the internal of voltage format preserving encryption, how we do. When we go and set up the voltage, like it's we will assign a key for each and every line of business. So data encrypted by using one line of business cannot be compared with the other line of business data, which is encrypted by using another encryption key. So the same data encrypted outside of a one line of business it's not comparable until unless you go and decrypt and re-encrypt the same common key. The beauty about the format preserving encryption is if I'm encrypting like the 10-digit string, like it's going to 10-character length string, it's going to the output going to be a 10-character string only. Because of this, we no need to change any data model or no need to change our code to go and comply with this requirement. It can be implemented in RDBMS, it can be implemented in any big data, Hadoop, Hive, flat file. Even we implemented in GCP, BigQuery, and Dataproc, other third-party tool, business intelligence tool as well, like we implemented. So it can be implementable anywhere, wherever the data goes. For the next one is the de-identification. Like, hey, this is like very less restrictive de-identification. We call something like use format preserving hashing. This also follows the same standard as like it's a format preserving encryption. If it's an encrypt 10-digit 10-character string, it's going to output 10-character string only. But it's like it's a one-way hashing, we cannot hash it back. This it will be used for only our internal purpose because this is less secure or like it's somehow easily crackable or easily go and identify one record individually and map it back because we can encrypt any person's we can hash any person's data and create a reference table and use it because it has a little bit of risk. So it's just not used like it's other than internal purpose. Coming to the tokenization standard where like is which follows a safe harbor method. The earlier one is like a statistical reference method, so which has a little bit of risk of identifying. This one, data token based one, it does not have such a risk, like it's almost close to zero. And HIPAA says we have to strip off certain information, first name, last name, and street address. If you see here, the left side is the plain text, the right side is like what our de-identified data. But when we de-identify, we will create a token by concatenating first name, last name, date of birth, and then gender. These three data, it will be concatenated and it will be a token generated by doing a one-way hashing. Internally, how it works, we use product called DataVent, which has a portal, its own portal. the portal has like a site-specific sort and also site-specific encryption key. This tokenization is a two-step process. First, in the first step, it will do one-way hashing of by using a secure hash algorithm 256. By using this algorithm, it will do the one-way hashing. And then it's apply encryption by using a site-specific key. And once it encrypted, it will apply base 64 encoding, which will standardize the length of the output always to be a 44 character length object. Okay. This is how like we generate the token. This data, whatever the de-identification data, we can share legally, we can share with somebody like outside of our organization, even within our organization, to combine with like it's a multiple line of business data in a single place. Okay. Before that, we cannot do it. And now you'll go and look at the use case of, hey, if I want to share the data with somebody outside of my organization or outside of my line of business, how it can be done. When you do decided to share to some other line of business or any other party, first you need to establish the relation, and we need to agree upon a shared encryption key. For what it will be used, because whenever we create the tokenization, it was encrypted by using a site-specific encryption key. So that key is only belongs to the parent organization. If you want to share, what we have to do is, the first step, we have to decrypt the data by using our own parent site key, which will produce the output is like some hashed value, a secure hash 256 value. Once we have the value back, and it will be re-encrypted by using a shared key so that it can be data transferred to our agreed partner. That's what the last step it will produce. The output is going to be a 44 character, doesn't matter like length of the source. So it's consistent. Once we produce this, like it will go to our partner side, like the partner receives data, and they will be running operation called receive from. What it would happen, they would have a shared key, what like we agreed upon, we are using it. By using a shared key, they will decrypt the data and re-encrypt the hashed value by using the parent key. Then only they will have like it's a standardized token, and the standardized token can be compared with the existing data in the premises. Okay. This way, like this data can be shared not only the like internal line of business, and also like we can share with like a third parties and like our other data partners. We do use other data protection mechanism. It's called the column level restriction. If in any data warehouse like or any other database, like if you don't want to share certain columns, we will be using this. It's most of the time like it's provided by the software manufacturer itself. And the next one is a row level restriction, where we don't want to certain clients information we don't want to share, means we will put a restriction based upon the rules or like them security group or like them department where they are belongs to us. And the restriction, it will be implemented. The third kind of a one, like which is like is a very trivial or like is a fundamental of like any data security. It's server-side encryption or at rest encryption. So all the server-side encryption and at rest encryption, it will be implemented by using a customer managed keys. That's a standard what followed. So these are the certain procedures what we follow secure our data. I'll stop here, and if you have any question, you can ask me. Yeah.
So I will start.
Actually, algorithm biases comes with the based upon the input data. Okay. It's most of the time negligence or like kind of training data what we use. To overcome that, like is our organization has special team to go and validate the data. Is it um, trained on proper data? It's a balanced data. It has all the inputs. And another thing is like it's in a healthcare industry, the language and race are like restricted of field. We cannot use that these two field to go and predict like our analysis. So basically, it's a fundamentally it's a block. Like it's if you go and need to look at the data, you need further clearance from our data governance and privacy office. It's not that easily available to feed it into the algorithm until unless it's specifically mentioned. So in that way, the language and race are not included in any of our analysis. Any other question? Thank you. Thank you, everyone. Thank you.